Hi everyone, we're going to be tackling section 1.6 in this video, and this chapter or this section has a lot of information in it, and it's kind of an overview of how to solve other types of equations. We will use some of these techniques later on, and we will remind you again when we see them again, but I just wanted you to kind of refresh your memory as to all the different types of equations that are out there and how you went about solving them. So here's our first one. We have 3 over x plus 3 minus 2 over x minus 3 equals a negative 12 over x squared minus 9. We do not like to deal with fractions. Students, they are complicated, messy, so what we're going to do is clear our fractions. So we clear the fractions by multiplying by that lowest common denominator. And in order to find the common denominator when we are dealing with expressions, we need to find the common factors. So I'm going to be factoring each piece. These cannot be factored further, but this is a difference of squares, and it does factor into x plus 3 and x minus 3. And there was a section in that prerequisite chapter on reviewing some of these complex fractions or just rational expressions, how to deal with them. So we did a lot of practice in that section as well. So we're going to clear these fractions now by multiplying everything by that lowest common denominator. So I'm going to kind of put this in brackets, and I'm going to multiply both sides of my equation by this. And this is something I can do with an equation. If it was an expression, I could not do that because I would be changing the value. But when I have an equation, I can multiply both sides of my equation by something. So when I multiply this guy by that, you'll notice that those x plus 3's will cancel each other out, and I'll be left with 3 times that x minus 3. Moving to the next one, I will have that minus 2, and the x minus 3's cancel, and I'll be left with that x plus 3. And when I multiply this side of the equation by that, the whole bottom is gone, and I'm left with just that negative 12. Now I can distribute very carefully. 2x minus 6 equaling negative 12. So 3x minus 9 minus 2x minus 6 equaling a negative 12. I'm going to combine my like terms. The 3x and the negative 2x gives me a single x. The negative 9 and the negative 6 gives me minus 15 equals to negative 12. I will add 15 to both sides. So x is 3. One thing I do need to check when I have this is I can lose an answer or gain answers, and by substituting this back in, I'll see that this is going to make that second fraction have a 0 in the denominator, so I do have to throw it out, which means I actually have no solution. So when you get to that answer, double check to make sure it does not make any of your original denominators 0. If it does, you have to throw it out. This case, we did have to throw the only one we came up with, and we do get no solution. It is possible when I do this clearing of the fractions that I have a quadratic, which we learned how to solve in 1.4, and I sometimes will get 2 answers there. It's possible that I can keep one, throw out one. It's possible I keep them both. It's possible I have to throw them both out. So you do need to check. Here's another problem. Here we have x cubed plus 3x squared minus 4x minus 12 equal to 0. Anytime we see a power higher than 1, so an exponent like squared or cubed, our technique is going to be to set it equal to 0 and try to factor it. Like the quadratic, we try to factor first. This is a cubic, and we will learn and spend more time with more cubics later on, but we'll also notice this has 4 terms. So this one, when I see 4 terms, I automatically think factor by grouping. So out of these first 2, I'm going to pull out that x squared, and I'm left with an x plus 3. For my factor by grouping to work, I'm going to need that x plus 3 to show up. So I'm going to pull out a minus 4. And I do get that x plus 3 showing up. Pulling out now that x plus 3 common piece, I'm left with the x squared minus 4 equaling 0. Now I can set each factor equal to 0. Subtracting, we get x equals negative 3 here, so I subtracted 3 from both sides. Here I'm going to add 4 to both sides and then take a square root. But if I take a square root, I have to remember the plus or minus, and the square root of 4 is 2. So taking square roots of both sides. You could have, if you had seen it, and some of you probably did, this can be factored further. That x squared minus 4 can be factored into x plus 2 and x minus 2. And in that case, you see the plus or minus coming out. So here we would not have needed to remember that plus or minus 2 because we see them when we see those factors. And then setting each factor equal to 0. So x plus 2 equal to 0, x minus 2 equal to 0, subtracting 2 here, x is a negative 2, adding 2 here, x is equal to a positive 2. So we do get 3 answers. We get negative 3, 2, and negative 2. All right, let's move to some more. What do we do when there's square roots? Well, the key to a square root is to, first of all, isolate that square root piece. So I'm going to move this 1 to the other side. So I'm going to subtract 1 from both sides, and I get 2x minus 1 equals a negative square root 2 minus x. Then the technique is to square both sides. And remembering when I square the 2x minus 1, I have to remember it is 2x minus 1 times itself, which means I am going to need to FOIL. So 2x and 2x is 4x squared. My outers minus 2x, my inners minus 2x, and my last plus 1. So there it is, squared. Squaring a square root lifts that radical. Squaring the negative makes it positive. So this side just becomes 2 minus x. It is a quadratic, so I'm going to combine my like terms first of all. So I get 4x squared minus 4x plus 1 equal to 2 minus x. It's a quadratic, so again, our technique is to set it equal to 0. So I'm going to move this x to the other side. So I'm going to be adding x to both sides. So that gives me a minus 3x. And I'm going to subtract 2, so minus 1. And now I want to factor it if possible. My leading coefficient is not 1, so I'm going to come up with 2 numbers that multiply together to give me a negative 4, that add together to give me a negative 3, and that is 4, a negative 4, and 1. So I'm going to rewrite that negative 3x as a negative 4x plus x. Out of these first two, I'm going to factor out a 4x, and I'm left with x minus 1. Out of these two, I'm going to actually just take out a 1, which really doesn't do anything, and I'm left with that x minus 1. I'm going to go over here. Factoring out the x minus 1, I have 4x plus 1 equal to 0. Set each one equal to 0. So x is equal to 1, or x is equal to a negative 1/4, subtracting 1 and dividing by 4. When you square both sides, you are going to want to double check to make sure that they work. So substituting the 1 in here, This side would give me 2. Here I'd have 1 minus, and putting a 1 in here, I'd have 2 minus 1, which is 1. The square root of 1 is 1, and 1 minus 1 is 0. So this one does not actually work. The reason is when we squared both sides, one side was positive, the other side was negative, and squaring them made them equal. Substituting in this negative 1/4, all right, a negative 1/4 times 2 is a negative 1/2. So I'm going to kind of write that up there, negative 1/2. And here we're going to have 1 minus, let's see, 2 minus a 1/4, that's 2 plus 1/4. 2 is 8/4, so 9/4. The square root of 9/4 is 3/2. 1 minus 3/2 is a negative 1/2. That one works. So we're going to keep both of them. All right. Another problem. What if I have more than one square root? Ooh. The technique here is to keep your square roots on one side, each on one side. And then we're going to square both sides. This one's going to be a little bit ugly, but we can do it. Squaring this side lifts the radical, so we just get that 3x plus 1. Here we have to remember it's going to be FOILed. So we're multiplying this by itself. So multiplying the first gives me 2 times 2, which is 4. My outers is going to be 2 square roots of x plus 1. My inners is another 2 square roots of x plus 1. And then my lasts are that x plus 1, because I'm multiplying the square root times the square root lifts that radical. I'm going to combine all my like terms. So I still have that 3x plus 1 here. I have 4, and the 1 gives me a 5. I have an x sitting there, and then I also have 4, and I still have that square root in there. Which means I'm still at a problem that I have to deal with. The method is to isolate the square root, so I'm going to move the 5 and that x to the other side, so subtracting 5 and subtracting x. So I'll get a 2x minus 4 equals 4 square roots x plus 1. And we're going to do it again. So squaring both sides. Okay, so I'm going to be squaring that 2x minus 4. So 2x minus 4 times itself. So 4x squared minus 8x minus 8x plus 16. Here, squaring both pieces will give me 16 times x plus 1. Combining some like terms, 4x squared minus 16x plus 16 equals 16x plus 16. It is a quadratic, so I am going to move everything to one side. So I'm going to subtract 16x from both sides, so that becomes a 32x. Subtracting 16 makes those disappear. I can factor out a 4x on both of these, and I'm left with an x minus 8. So either 4x is equal to 0, or x minus 8 is equal to 0. So either x is 0 or x is 8. And again, we are going to double check all of our answers. So substituting in here, we have 0 plus 1 is 1. So the square root of 1 is 1. It's supposed to be equal to 2 plus the square root of 1. So 1 is supposed to be equal to 3. That does not work. We gained an extra answer. Substituting in the 8. 8 times 3 is 24. Plus 1 is 25. The square root of 25 is 5. So 5 is supposed to be 2 plus, and 8 plus 1 is 9. So 5 is equal to 2 plus 3, which it is, so we do have an answer, x equaling 8. I'm going to stop this video right now, and I will come back for the last 2 examples on another video. I like to keep my videos short so that they don't get too overwhelming.